Hello, everyone, and welcome to the February Recreational Astronomy Night Meeting online edition of the Royal Astronomical Society of Canada Toronto Centre. I'm Paul Markov, and aside from introducing the speakers, I also search for presentations for upcoming meetings. So if you have a presentation in mind, please get in touch with me. We have openings for the April and later meetings. I would like to point out once again that because we're no longer tied to the schedule at the Ontario Science Centre, where we used to hold our meetings are now going to be on the first Wednesday of the month, at least until we get to go back to the Science Centre. Easy to remember, first Wednesday of the month. Before we start with the presentations, I would like to thank in advance our technical team. As usual, they do a wonderful job every time we hold these meetings. That team is made up of Andrew and Betty Reed, Blake Nancarrow, Ward Legros, and Anya Chiluchi. Thank you guys for making these online presentations possible for all of us. We have 3 speakers this evening, and I expect we will be done around 9:30 as usual. The speakers are Arnold Brody presenting The Sky This Month, followed by our young astronomers, Artash and Arushi Nath, with the do-it-yourself asteroid astronomy using Python. And then our third speaker is Blake Nancarrow. He'll talk to us about weather forecasting resources for amateur astronomers. And as usual, our president, Tom Luton, will wrap up the evening with announcements. If you have questions, please enter them in the YouTube chat box, and Ward is going to ask the speakers your question on your behalf. And if you're attending the meeting for the first time, whether you're a member or not, please let us know again by messaging through the chat box. So I think we're ready to get the meeting started with our first speaker, Arnold Brody and The Sky This Month.
Well, thank you, Paul. Thank you, Paul, and hello, everyone. Tonight, I will cover the period from tonight to March 2, the night before our next online meeting. Dates, times, and simulations you'll see are based on the Eastern Time Zone. I also did The Sky This Month for February last year at the Ontario Science Centre. Then the pandemic hit and we've not been back. Fortunately, our meetings have continued uninterrupted, as Paul was just mentioning, thanks to the AV committee and volunteers streaming our meetings online, and I'll repeat their names as a shout out to Andrew and Betty Reed, Ward Legros, Anya Chiluchi, and Blake Nancarrow. Thank you for keeping us connected. A quick review of space missions and then jump into February observing. Now, there are hundreds of astronomers whose birthdays are in February, according to the Born Glorious website. For brevity, I've picked 2 giants who opened the door for modern astronomy. First, Copernicus, born this month in 1473. He disliked the Earth-centered universe of Aristotle Ptolemy with planets riding on epicycles. So he put the planets, including Earth, in orbit around the sun, and the epicycles were gone. Simple. He published his theory in De Revolutionibus Orbium Coelestium on the revolutions of the heavenly spheres. And knowing the danger his book would put him in, he waited until his last days to publish. Copernicus was followed a century later by Galileo, born in February 1564. Now, Galileo turned his handmade 37mm telescope to the sun, moon, planets, and stars in the sky in the early 1600s, and in 1610, he reported his findings in Sidereus Nuncius, the starry messenger, which challenged conventional wisdom and drew the ire of the church. He was familiar with Copernicus's sun-centered model and promoted it in dialogues concerning the 2 chief world systems, which led to his conviction for heresy and house arrest. Galileo is known as the father of modern science through the use of experimental evidence to test theories. Of the many astronomical events with anniversaries this month, here are 3. In February 1845, the Leviathan of Parsonstown saw first light and became the world's largest telescope for 72 years. In February 1930, Clyde Tombaugh found Pluto with a comparator machine that showed a dot moving between photographic plates that he exposed through a 330 millimeter telescope at the Lowell Observatory. And in February 1974, Mariner 10 became the first spacecraft to use a planet, in this case Venus, for a gravity assist on its way to Mercury. Now for some mission updates, on January 14, Blue Origins successfully tested their suborbital space tourism system with the new Shepard booster, reaching the planned apogee and successfully recovering both booster and capsule. Revenue from tourists taking the 11-minute trip above the Kármán line, starting later this year, we believe, will help fund missions under development, such as the Blue Moon crew and cargo trips to the moon. On January 17, Richard Branson's Virgin Orbit had a successful second demonstration of their liquid-fueled Launcher 1 rocket that was air-launched from under the wing of Cosmic Girl, a modified Boeing 747-400. They deployed 10 CubeSats for NASA in the demo. Launcher 1 demos are now complete, and VO bookings have bookings with the US Space Force, UK's Royal Air Force, Swarm Technologies, and others. Elon Musk's Starship SpaceX, I should say, they ran a second Starship belly flop landing attempt yesterday. And like serial number 8, serial number 9 failed to stick the landing due to a Raptor engine not reigniting. Meanwhile, SN10 stands on an adjacent launch platform waiting its turn to try later this week or next. Hopefully, it was paying attention. Every 26 months, as Earth approaches Mars, a 2 to 3 week launch window opens for efficient trips to the planet. This animation shows the InSight mission using the 2018 window. This past year, a Mars window opened in July, and missions from 3 national space agencies jumped through it. The Emirates Mars mission, HOPE, will enter into Mars orbit on February 9 and become Mars's first weather satellite as it studies the atmosphere and watches windstorms. The China National Space Administration sent Tianwen-1 on its way to Mars on July 23. It is an orbiter with a lander and rover. Orbital insertion will occur on February 10, with the lander and rover landing sometime in May. NASA's Mars 2020 mission launched on July 30. It consists of the Perseverance rover and the Ingenuity helicopter. And on February 18, Perseverance will use the Sky Crane to land into Jezero crater. Okay, now on to observing. For the astrophotographers, the sky is as dark as possible, with the sun at least 18 degrees below the horizon for about 10 3/4 hours tonight, down by 49 minutes a month from now. Visual astronomers can enjoy observing an extra hour by including astronomical twilight. An outburst of activity on the sun's southern hemisphere back in November signaled the onset of solar cycle 25, but activity has taken a pause since. Here's an image of the sun taken 4 days ago showing a spotless complexion with 0 sunspots, 0 new regions. The view from stereo A does not promise any activity that will rotate into view. Stereo A satellite trails Earth on our solar orbit by 60 degrees, so our views do overlap. Stereo B is 60 degrees ahead of Earth, but it failed 5 years ago. A team led by Scott McIntosh has made a bold prediction for solar cycle 25, shown here in red. They say cycle 25 will be augmented by a secondary cycle and could reach maximum in just 2 years in 2023, with an awesome sunspot count as high as 250, more than double the 120 max that cycle 24 achieved. And it would be more than any sunspot count ever previously recorded. That's enormous, and a stark contrast to the steady decline we saw in sunspot numbers over the last 4 cycles. NOAA, NASA, and the International Solar Energy Society say 25 will be just like 24, but that's their estimate in blue, and green is the historical average. Now, how cycle 25 plays out will help space weather forecasters perfect their models that are needed for planning crewed missions to the moon and Mars. As for the sun in our sky, it climbs 9.5 degrees from 30 degrees up tomorrow local noon to 39.5 by March 3, squeezing the night window as a result. If you're searching for any cycle 25 activity, you're looking through 2 atmospheres at local noon at the start of February, on its way to a minimum of only 1.1 atmospheres that you'd be looking through when you examine the sun on the summer solstice when it gets as high as possible. So your resolution examining the sun through your Coronado or other solar filtered scopes will improve over the next 4 months as the sun climbs higher. Now on to the moon. This animation from NASA's Visualization Studio shows the moon's phases, vibration, and distance from Earth this month. You'll notice it reaching apogee around first quarter on February 19, and then dropping towards perigee in early March as the moon ages towards last quarter again. The window for deep sky observing without moon interference is opening now and runs for the next 10 to 12 days. The last quarter moon is tomorrow with new moon a week later. And perigee and apogee occur a day before last and first quarter moons respectively. February's full moon, commonly known as the snow moon or hunger moon, rises on the evening of Saturday, the 27th. Now, asterisks you see in this calendar identify dates with interesting moon events. Let's check them out, starting with Monday, the 15th. On that day, lunar libration tips the northeast limb of the moon in our direction, giving us a chance to take a peek at the floor of crater Heian and study Mare Humboldtianum, one of 2 lunar mare named after people. Situated next to the unseen side of the moon, Humboldtianum was named after Alexander von Humboldt, a prominent 18th and 19th century explorer of unknown lands. By the way, the other mare named after someone is Mare Smithii, named after British admiral and astronomer William Henry Smith, a contemporary of von Humboldt's. That same night, a few minutes before 9 p.m., you can watch the dark limb of the young moon occult 29 Ceti, a magnitude 6.4 star, so you will need binoculars or a telescope to see it. Have you heard of the lunar S? It was found by Blob Rana several years ago, and it's possible to catch it on the moon's southeast quadrant near crater Theophilus on February 17th. On the 19th, there will be a lovely sight high in the southwest as the first quarter moon glides between the Hyades on the left and the bright Pleiades on the right, with the red glow of nearby Mars right behind. The Hyades is very close, only 153 light years away, and dense with hundreds of stars, the brightest forming the V shape of the Taurus bull's face. By the way, the bright red Aldebaran, the eye of the bull, is not a member of the Hyades. That's it right here. It's less than half as far away at only 65 light years. And do you see this orange star just east of the moon? That's 43 Tauri, magnitude 5.5. A K2 red giant, and it's about to be occulted by the dark limb of the moon. Here's a telescopic view, a mirrored simulated view through a small refractor. That's why it's flipped around. And when we look through a telescope, we can see a second star about to be occulted. It's a 7.7 magnitude type double. Well, maybe it will wink out in steps. After watching the occultation, you can turn your telescope onto the moon and study a number of features along the terminator. The uneven surface of Mare Imbrium is highlighted by the shallow angle of sunlight illuminating the eastern side of the Sea of Rains. Mare Imbrium was formed 3.8 billion years ago, towards the end of the late bombardment period, from a strike by a protoplanet asteroid estimated to be around 250 kilometers in diameter. The impact created a basin that was 100 kilometers deep before the surface rebounded and filled with lava, which you can now study in the shallow sunlight. It's a good opportunity to study the tall, rugged mountains, Montes Apenninus, that borders the southeast shore of Mare Imbrium. The range is over 5 kilometers high in places and is well defined by its shadows. The moon will be below the horizon for us when the lunar X and V are perfectly illuminated along the terminator, but we can still study them and the craters whose rims formed them in sunlight on the 19th. And we can watch sunlight begin to reach the floors and central peaks in the large craters in the southern highlands, such as Mauritius. Now, the moon is at its highest in winter, so you should be looking through only 1.1 air masses when studying these features. A very good opportunity. And speaking of opportunities, there's another one to see the advancing dark limb of the moon cover a magnitude 6 star on Sunday, February 21, around 10:18 p.m. On February 24, the nearly full moon passes close to M44, the Beehive cluster in Cancer. The inner circle is 4 degrees wide, the view you would get with an 80 millimeter refractor and a low power eyepiece. Of course, the view inside that circle should be flipped left to right to match. The other circle is a 7-degree field of 10 by 50 wide field binoculars. And I think those would be the preferred equipment for looking at that lovely sight. And here we see the moon less than 10 arc minutes from 4.6 magnitude Gamma Cancri at 8:49. Back in October, I talked about a great parade of planets across the sky. Well, the parade has marched down the street and around the corner and is out of sight, and all we have left now are Mars and Uranus lingering in the west. Tonight, Mercury sits less than 10 degrees from the sun and getting closer for the next few days, making it unsafe or impossible to see it. On March 2, Mercury is visible in the east before sunrise, but very low due to the shallow angle the ecliptic takes at sunrise this time of year. There will be more favorable times to catch Mercury, such as May 15, when Mercury will be 19 degrees high in the west at sunset, at a convenient evening hour, not pre-dawn. It will be much warmer then, and the bugs won't be out yet, so that might be your best chance to see Mercury. Venus is very low in the west after sunset tonight, and even lower as we enter March. If you can spot it in a telescope, and please wait until after sunset to try, you'll notice it becoming circular in phase. This convinced Galileo that Venus was orbiting around the sun. There's a better chance to observe Venus in late summer and early fall, and here's a teaser showing Venus over 30 degrees high in the east on September 8 before dawn. And although you do have to get out before dawn, it's rather late in the morning. Here we see 6:49. Well, if you came out at 6 o'clock in the morning, Venus will be very high and the sun won't be up yet, so that will be an excellent opportunity to see Venus this year. That would be later in the year, in September. Mars is a fading red dot in the west, climbing higher throughout the month. We're orbiting directly away from Mars, so it shrinks and fades significantly. And you might not see any features on the tiny disk, but you might want to give it a look anyways, knowing the amount of attention that Mars is getting with those 3 missions arriving there later this month. We don't fare much better with the outer gas and ice giants. Our sight lines towards Jupiter and Saturn, towards Pluto or towards Neptune, those sight lines pass right by the sun, making those objects pretty hard or impossible to see. Now, Jupiter and Saturn, they have recently passed superior conjunction behind the sun, and they will gradually return to the pre-dawn sky as Earth races around the sun to move it out of the way. But we're going to need to wait until spring to really start observing those gas giants in any detail. Uranus lingers in the west like Mars, with Earth pulling away. Uranus is a very small blue-green disk at 3.5 arc seconds, found 8.5 degrees east of Gamma Aritis. And that's it for planets. Not much now, I'm afraid. There are 2 comets crossing the southern sky this month. Comet Neowise will pass through Monoceros under the feet of the Gemini twins and past a few open clusters in Auriga, coming within 35 arc minutes of NGC 1907. Meanwhile, Mach-Holtz travels eastward from Cetus to Orion, and below each are magnitude estimates over the last week or two by observers using 8 to 12-inch telescopes. And those estimates of 11 magnitude or brighter suggest that we should still be able to catch those comets through similar equipment this coming month. 2 asteroids pass through opposition this month, 113 Amalthea and 29 Amphitrite. Asteroids, of course, will travel at the quickest inner sky when they're at opposition. And if you would like to visualize an asteroid's orbital motion in real time or record it, you can watch Amphitrite cruise within 10 arc seconds of a pair of closely spaced stars on Monday the 15th. Closest approach is around 1:30 Tuesday morning. And here we have a simulated mirror image view through an equatorial 10-inch SCT and a 9mm eyepiece. We're at the end of twilight around 7:30 when these objects first become visible. And in 4 hours, Amphitrite makes its closest approach. On the new moon night of February the 10th, a 40-kilometer wide asteroid, 515 Athalia, occults a magnitude 12.5 star in the constellation Gemini around 2353 in southwestern Ontario. The occultation is expected to last up to 6 minutes on the center line, although there is a lot to be learned about the shape of an asteroid by taking timings across the width of the eclipse path between these 2 blue lines. Here's an example of the profiles of the twin bodies of asteroid 90 Antiope, based on timing submitted by 37 observers spread across that particular eclipse path. If you are interested in learning more about timing occultations and making submissions, you can visit IOTA, the International Occultation Timing Association, at the 2 websites shown here. A week later, on the 18th, there is another occultation that passes across southern Ontario, including Mississauga, Etobicoke, and downtown Toronto, south of the Eglinton-St. Clair. The magnitude drop is not as great, but enough to detect with astrocamera tracking the star. So if this sounds like something you'd be interested in trying and have the needed gear, you have 2 asteroid occultations, only 8 days apart, to try your skills on. So good luck with that. I'm sorry, there are no meteor showers this month. They will resume in the spring. So when it comes to observing the solar system this month, we can monitor the start of solar cycle 25. We can study the moon, watch a couple of comets, and maybe watch occultations involving the moon and asteroids, and that's pretty much it. We'll need to wait a month or 2 for most of the planets to return to the pre-dawn sky. Until then, let's check out the stars in deep sky. If you're out for that occultation of 43 Tauri by the first quarter moon on Monday the 19th, chances are you'll also explore the sites in Orion. Now, while you're there, there are 4 double stars from the Double Star Observing Certificate in the constellation. And here's how they look in simulated 6 arc-minute circles, inverted as though you're looking through a Newtonian or reflector scope. Now, 41 Orionis, otherwise known as the trapezium, I don't think it will be sitting in a dark field as suggested here. That's because it's in the middle of the Orion Nebula, so there's lots of glowing gas and dust, I would expect in your view. On the 9th, Demon Star Algol drops in magnitude by 75% when bigger and dimmer Algol B passes in front of brighter Algol A. The 2 stars are so close together it takes just over 2.5 days for the pair to complete 1 orbit around their barycenter. When the dimmer B slips behind A, the drop in magnitude can only be measured with equipment. Algol is bright at magnitude 2.1 at max, and its entire eclipse can be monitored with your eyes alone. You can watch an Algol eclipse already underway at nightfall on the 9th. Algol will already be dimmer than Almac or Gamma Andromedae, but how dim? Will it be like 2.9 epsilon Persei? Will it be like 3.0 delta? And which, by the way, these two stars is a good test of discerning a 0.1 difference in magnitude. By 8:35, Algol will be at minimum as dim as magnitude 3.4 Alpha Trianguli and stay there for 2 hours. 9:35 is the midpoint of the 2-hour minimum. Alpha Trianguli will probably look dimmer due to atmospheric extinction because it's 20 degrees further down, closer to the horizon. So you're looking through more atmospheres. It may not appear as bright as Algol. It may be even dimmer. But if you're observing past 10:35, Algol will begin to rebrighten. Take a look every 15 minutes and compare it to its neighbors as it rebrightens. Another variable you can watch dim and rebrighten with your eyes alone is Delta Cephei, after which the Delta Cepheid class of variables is named. The star is pulsating as it has not reached equilibrium between the atmosphere wanting to collapse and the release of fusion energy in the core pushing back. This results in the star heating up and cooling off, causing a fluctuation in brightness between 3.48 and 4.37, with a 5.4-day period. At its brightest, it's nearly the same as Zeta Cephei, and slightly dimmer than Epsilon when at minimum. You can compare Delta with its neighbors on any clear night since the constellation Cepheus is circumpolar. Although when it's higher up in the sky, you get a better, clear look at the magnitudes. Now, the period of fluctuations tells us the absolute brightness of a Cepheid-type star, and the star's apparent brightness depends on its distance. So by comparing a Cepheid's actual versus apparent brightness, we can tell how far away it is, or how far away a galaxy is with a Cepheid in its arms. That's how Edwin Hubble determined the Andromeda Nebula was actually a galaxy far outside our own, by discovering a Cepheid in Andromeda in his photographic plates that he took in 1924. Now, if you would like to learn more about observing variable stars and submitting magnitude estimates, visit AAVSO at the website shown here. They will give you some training on how to observe variable stars, and then you can be able to make submissions to them. With Valentine's Day on February 14, I would like to suggest a few deep space targets along that theme. Some of you may remember these targets from when I did the sky this month last year. First on our list is the Heart Nebula. We get a bonus with the Heart Soulmate, the Soul Nebula, only 2 degrees away. This gorgeous image of the Heart and Soul Nebula was produced by Adrian Aberdeen from his apartment balcony in Toronto, and is found on our forum's astrophotography section, where you can find Adrian's write-up and imaging details. Now, whereas Adrian pushes the blue component a lot in his post-processing, it's his favorite color, the 2 nebulae grow predominantly in the red of ionized hydrogen. They can be viewed visually with moderate to large amateur telescopes under dark conditions. You can find the Heart and Soul Nebula 6 degrees north-northwest of Eta Persei, the star at the tip of the hero's cap. Do you see a heart-shaped pattern in the brighter stars of this open cluster? Maybe like this. The heart-shaped cluster is M50, discovered by Charles Messier in 1772 while observing a comet. It is a rich cluster with 500 stars, and it is still quite young at 140 million years old. It can be found almost halfway on a line between Alpha and Beta Montes Herodes, slightly closer to Beta. It's easy to find at magnitude 5.9. Next on our tour is the Rosette Nebula, also known as Caldwell 49, seen in this image by Jeff Booth. It's a large spherical H2 region, circular in appearance, located in the Monticeros region of the Milky Way galaxy. NGC 2244, or Caldwell 50, is the open cluster of stars found in the nebula's center, having formed from the nebula's matter, and are now exciting the leftover gas to glow red. The nebula and cluster lies some 5,000 years away and has an estimated mass of over 10,000 solar masses. Oh, and to encourage others, Jeff would like you to know that he imaged this nebula from his backyard in, quote, light-polluted Oakville. There is an easy two-step star hop that will take you to the Rosette Nebula. First, find magnitude 4.5 star 13 Montecorotus, 9.5 degrees east of Betelgeuse, almost one fist to the left. Next, with your telescope aimed at the star, slew south 2 degrees and the open cluster NGC 2244 will enter your eyepiece. The rosette has an apparent magnitude of 9, and the embedded open cluster will be easier to see at magnitude 4.8. To see the nebula surrounding this brilliant cluster, you will need dark skies and a narrow band nebula filter to dim down the cluster. This cluster is truly amazing. It is very young, at less than 5 million years old. Its brightest two members are fearsome O-class monsters, the most luminous stars in the main sequence. One is 450,000 times brighter and 60 times more massive than our sun, and the other is 400,000 times brighter and 50 times more massive. By comparison, Sirius is twice our sun's mass, Betelgeuse 11, Antares 12. Now, stars this massive exhaust their fuel in only 3 million years, putting an upper limit on how old this cluster can be. By the way, 12 Montecorotus is not a cluster member. It's around 500 light years away, not 5,000 like the cluster. Our final Valentine's treat is this merging pair of galaxies, NGC 4038 and 4039, located 45 million light years away in Corvus. Tidal interactions have resulted in two long streamers of stars, dust, and gas being ejected in curving arcs, resembling an insect's antennae. The original spiral structures of the two galaxies have fallen together to become the two lobes of a heart. The collision has triggered starburst, raising the nebulosity of each to magnitude 11, within the reach of visual observing from dark skies with 8-inch or larger telescopes. We can use the stars across the top of Corvus to locate the merging galaxies. Go from El Goreb to Gienah and continue that same distance, and you'll be less than a half a degree north of the merging galaxies. Being in Corvus, the galaxies do not rise very high in the south. On the new moon night of February the 11th, they rise at 10 p.m. and reach the meridian around 3 a.m. at a height of 27 degrees, and that's about as high as they get in southern Ontario. So these are the various online resources, the planetarium software used to generate the images, and I thank these people under Astro Images for their wonderful deep sky photography. Thank you. Any questions?
Thank you very much, Arnold, for a thorough presentation. I know it takes an awful long time to make the presentation, so thanks again for all the time you invested. Let's go to Ward. Any questions from our online audience?
Just one question from Blake right now. He was wondering what the source was who said that the next solar cycle was going to be so great.
Well, let me jump back to that slide and show it to you again, if I can. Well, let's see. And that was about the solar cycle 25.
That's right.
Yeah, this slide here. McIntosh and company, they are either funded by or work for the National Center for Atmospheric Research. So they're independent of the federal agencies such as NOAA and NASA. McIntosh, Scott, he says that there's a 22-year cycle. Maybe it grows and weakens, but he says it's going to merge with the normal 11-year cycle, and that would account for this terrific jump. If he's right, it's a major change in our ability to forecast solar activity, and that, of course, is important when we're contemplating space missions with astronauts in space for years, traveling to, let's say, distant planets, or orbiting Mars for a number of years. How much radiation is the sun producing? How can we predict it? This is a very interesting subject that's being advanced, especially with additional information coming from the Solar Dynamic Observatory. There's more data that's being used to try and figure these things out.
Excellent. Thanks very much.
You're welcome.
No other questions.
Okay, thank you, Ward. Thanks again, Arnold. I think we can move on to our second presentation. Artash and Arushi Nath will talk to us about do-it-yourself asteroid astrometry using Python. Go ahead, guys.
Thank you. Hello, everyone. Good evening. My name is Artash Nath. I'm a grade 9 student here in Toronto.
Hello, everyone. I'm Arushi, and I'm in grade 6. Today, I'm going to be talking to you about do-it-yourself asteroid astronomy using Python. So, I love asteroids. I'm really interested in them. Asteroids are objects which, just like planets like the Earth, orbit around the Sun. Most asteroids are found in between Mars and Jupiter, but our path is uncertain. Sometimes they go beyond that limit, and sometimes they can go very near the Earth. So when they go near the Earth, they're called near-Earth asteroids. But if they go very close, they're called potentially hazardous asteroids. And it's very important to keep observing these, because sometimes it's possible that one of these asteroids' path will intersect with the path of the Earth. So I got very interested when I found this out, and I wanted to learn as much about asteroids as I could. So I decided, why not actually look at asteroids and try to find the most information about them, like their velocity, for example. So I decided to start with 99942 Apophis asteroid. Why? Well, first of all, Apophis is one of the potentially hazardous asteroids, PHAs. And 2004, astronomers detected over 2.7% chance that this asteroid will intersect with the Earth or the Moon. And in 9 years from now, in 2029, the Apophis will go very close to the Earth, just 31,000 kilometers. So that's even closer than some of our satellites. So I wanted to take the first step to getting the data about this asteroid was to actually look at it. So for this, unfortunately, I could not use my own telescope that I have at my home because its aperture is around 15 centimeters. That meant that it was not enough to capture enough light to see dim objects, because this asteroid is quite dim right now. Like, it's around 18 magnitude, and when I started this project in November, it was magnitude 20. So I needed to use a robotic telescope, which means from my home, I can control the telescope very far away. So I started doing some research. The first telescope I found out was from the SLU website. They had a telescope called Chile 2. And it really helped me get into the basics of how to operate a robotic telescope, and I learned a lot of new things. But unfortunately, when I aimed it at Apophis, I was not able to see the asteroid, because still the aperture was not enough for the 3 centimeters. So I needed to look for a new telescope. I found out about iTelescope, where they give many telescopes and you were able to book reservation. I looked at a T11 telescope, deep space. But unfortunately here, it was still not enough aperture. So I knew I needed to get a big change so I can look at the asteroid. That's when I saw the Wilkes Telescope project from the Lascumber's Observatory. Their telescope had an aperture of 2 meters, so that would be enough for me to take observations. So I contacted them, and they generously gave me access a couple hours in my day to their telescope when they heard about my project and how I wanted to learn more about asteroids, especially Apophis. So now I had a good telescope to take observations. Now it was time to actually take the picture of Apophis. But for that, I would have to know where to look at because I can't just tell the telescope to point at Apophis because I have to be more specific. So I went on the Telescopius website where they gave me the right ascension and declination of my Apophis asteroid. But unfortunately, they only updated it every day, and as the telescope had a field of view relatively small, of 10 by 10 Earth minutes, it might have disappeared by the time I actually get from these coordinates. So I needed to get more accurate right ascension and declination coordinates. So here I found out about the NASA Horizons project, and here they gave me daily right ascension and declination coordinates of the asteroid. So that was good. Now I wanted to know when exactly should I take the observation because I need to know when is the asteroid going to be above the horizon and when it's going to be below the horizon. So here I had 2 options. Both Telescopius and the Wilkes Telescope website gave me this data. So as you can see in the graph, you can see that there's kind of like a peak. And the best visibility time was 14 to 17 o'clock UTC. So now with this information, I could go back to the NASA Horizon project and I could get that exact time. So I took the observation. The next day, the telescope had got the image. So I had to use a special software to open this image because it wasn't in a normal JPEG or PNG format, but it was in a bits file format. So when I opened the image, well, why bits files? Why not just a normal image file? The thing is, bits files have more than just the image. It also has lots of data about the image. For example, which telescope took the image, when did it take the image, what camera was used to take the image, and so on. So this would be useful later on. But when I opened the image, I didn't find multiple stars or objects as I had expected. I found a black screen with one dim object. So I was really surprised. I thought, did I underexpose it? Did I overexpose it? But I soon found out it was nothing to do with that. The thing is, I had to scale the image before I can use it. What does that mean? Well, when I get the image, the pixel brightness, it has a high range, so it doesn't take higher brightnesses better than lower brightnesses. So I had to decrease this range. So as you can see in these 4 figures, the first image is black, and then slowly you can see first only the bright objects, and then on the last figure you can see lots of objects. And actually, if you look at the 4 bottom graphs, you can see that the first one is from -200 to almost 500,000 is the range of the brightness. That was too much. And in the last one, you can see it's being reduced to 50 to 200. And the top image was good. So now it finished scaling my image. It was time to actually start. So first what I did is I inserted this image into the Worldwide Telescope software, and I was actually able to see the image in the whole sky. So this told me something, 2 things actually. The first, it verified that I took in the right right ascension and declination coordinates and put it in the telescope when I took the image because I could verify it with the software. And it also told me, because the thing is, when I get the image from the telescope, it sometimes is flipped or rotated. So this would tell me what was the rotation or flipping of this image. So, but if you look at this image, remember my main goal was to look at the Apophis asteroid. But how could I know which of these images is the Apophis? So I had to do something about that. So I decided to actually overlay the catalog on top of this image, so that, because the thing is, this catalog would tell me stars, but I was not interested in stars. I was interested in asteroids. So it would be able to remove all the stars from the image or tell me what the stars were. So I knew that none of those objects were the asteroid. So as you can see in the second figure, there is a red circle around some of these objects. That meant that these were recognized stars. But the problem was, there were still some or many objects that didn't have red circles. How did I know which one it is? So I overlaid the Minor Planet Center database, which told me about the asteroids, and I was actually able to find the 99942 Apophis asteroid inside the image, as you can see in the second figure. And you can see it's in the third line of asteroids. And if we verify in this image, we can see that the third one does not have a red circle on it. So that's verification, because I'm just verifying that it's the asteroid, because it wouldn't have a red circle. So I did the exact same process with the second image of Apophis that I did the next day, because I wanted to find stuff about the motion of the asteroid, which meant that I needed to find two images so I can see the difference of the right ascension and declination coordinate. So as you can see in this image, I got the asteroid in both the images, taken a day from each other, and got the exact coordinate of this asteroid. That was actually calculating the motion, or proper motion should I say, because we're only seeing a 2D image. So we can only see the minimum distance the asteroid traveled, because it might have traveled in the third dimension, but we wouldn't know. So I used Pythagorean for this. So finding the first side, so basically the change in declination, was quite easy. I just subtracted the two in arithmetic. But the right ascension was more difficult, because the right ascension actually, the distance between right ascensions actually change depending on if you're near the equator, where the right ascension distance would be bigger, and if you're near the poles, where it would be much smaller. So I actually needed to use the declination as well to find the distance in the two right ascensions. So I found a formula which basically I multiplied the difference in right ascensions with the cost of the average of the two declination coordinates from each image. And I found out in whole that the proper motion of Apophis was 3.13 multiplied by 10 to the power minus 6 degrees per second. So now, as I said before, this was a minimum.
And I'm also actually really interested in Python programming. So I wanted to replicate the steps of using those two images and locating the asteroid in those two images, but using no other software, just using my own Python programming skills. So there were 7 main steps in Python to finding the asteroid in the image, and I'm going to go through 6 right now. The first step was first importing the libraries I'm going to use in Python to help me with the image data. Libraries are just like functions or tools I can use inside my code to make the process easier. So I opened the FITS file using a library called AstroPy, which is really useful for astronomical data, and I displayed the image that's been read by the Python file on the right. And once again, just like Arushi said earlier in the presentation, I also got a black screen with very few stars, just one dim object in the upper left. So my second step was to scale the image, the pixel values inside the image, so I could actually see objects inside it. And I did this based on the standard deviation and the mean of the image. So on the right, you can see the scaled image, which has much more objects inside it. Third step. So I needed more information on this image. And the FITS file, as Arushi explained before, is not like JPEG. It doesn't just store the image. It also stores a header that has a lot of useful information about the image. And there were 4 things I used Python to extract these values from the FITS file. The first one was the right ascension and declination of the center point of my image. The second one was the pixel scale of each pixel in the image. And the pixel scale is really just the size of each image, the size of each image in degrees. For example, if our camera was taking a 10 degree by 10 degree image and had 100 by 100 pixels, then each of the pixels would be 1/10 of a degree by 1/10 of a degree in pixel scale. Third was the CCD size, and this was just a number of pixels inside the image. And finally, the focal length of the telescope was also taken. Now, I had my image, but I didn't know what of these objects, like before, was the asteroid. So I queried a star catalog from the United States Naval Observatory, which has a huge catalog of all the known stars across the skies. So I took the stars from the catalog that were around in this image and overlaid them onto the image. So at the bottom, you can see in the original image that I took from the previous slide, and you can also see a lot of red circles that have been overlaid on this image. And these red circles are the known stars from the catalog. But you might also notice that they don't match any of the stars on the image. And you know what? This is because they need to be rotated until they match the stars on the image. So I created another Python function that would rotate all these small circles until it found the best fit. So on the right, after the program rotated all the circles by 180 degrees, which is just a flip, all the red things overlay on most or on a lot of the stars in the image. So here's the original image I had taken from the left, and on the right is the image, but it's overlaid with the star catalog, known stars. And here we go, on the center, we see our bright object that isn't surrounded by a circle, and that is our asteroid. So I did the same process with the second image, so I was able to locate the asteroid using my Python program in both the images. And I did the same process of calculating the distance between these two, the asteroid over the time, and got the same speed of the asteroid as we did using the astrometry software.
Oh, just like to clarify one thing, is that you might notice that these images that you can see are different from the images that I took from my software. And this is because we didn't have enough time yet to actually do the same process with the Apophis asteroid. So this actually is a different image with a different asteroid. And this project wouldn't have been possible without two things. First is the actual bulk telescope project, which gave us time which actually we were able to get the actual images so we can perform all this analysis. The second is the Berg-Gaffney Observatory and the Abbey Ridge Observatory, where we were able to get test images from their observatory. Thank you. I hope you enjoyed our presentation. I'd be happy to answer any questions if you have any.
Thank you.
Hey guys, this is amazing stuff you're doing. You're on your way to turning professional. Congrats. Let's go to Word. Any questions for the guys?
Hi, one question from Blake for Arushi. Did you use FITS Liberator to stretch and scale the image?
Actually, for scaling the images, I used a software called image, DS9. So I
Excellent.
imagine many softwares are possible, but that's the one I found.
Fair enough, David. Your skills in coding, Artash, are pretty impressive. Well done.
Thank you.
No more questions?
No more questions.
Okay. Thank you, Word. Thank you again, Artash and Arushi, for your presentation. Well done. Let's move on to our next presenter. We have Blake Nancarrow. He'll talk to us about weather forecasting resources for the amateur astronomer. Go ahead, Blake.
Am I running into the same problem as before? You got my audio? Good. Okay. Thank you. Appreciate it. Thanks to the team. Lots of work going on behind the scenes. So my presentation is about weather forecasting for amateur astronomers. I hope that I'm going to be able to help you better predict the future and have better astronomy sessions, more success. Hopefully you can avoid driving a long distance to get rained out for both visual or imaging session planning. The instrument that's showing on this first slide is an old classic barometer. If you could only have one instrument, boy, it would be the analog barometer, because you can know what your current air pressure is. That's the black needle that's showing in this diagram. So that's the current air pressure. You have to calibrate these for your local location and elevation. But once you've done that, you've got your current air pressure. So that tells you what the weather is sort of right now and what's imminent in the next few hours, kind of thing. But they usually have a movable needle. And what you can do is set that needle or that hand to what the air pressure is now. And then you come back later and you know if the air pressure then has been increasing or decreasing. And that's really important. You want to know the trends for barometric air pressure, because then that's going to tell you whether clear skies are ahead or precipitation is ahead. And you can see there's little icons on this barometer. There's a sun, there's a cloud, there's rain. And if the air pressure dropped really rapidly, well, take cover. There's some severe weather coming through. So again, the old barometer is kind of amazing. And maybe if you've got a weather station at home, maybe you've got an outdoor sensor and it's you have the console in the kitchen or in the living room or something like that, and it shows barometric air pressure. I hope it shows trend, maybe a little up or a down arrow. And again, that can be really useful information to figure out what's going to happen over the next day or so. This presentation, Paul Markov asked me to do this presentation based on a discussion that was happening in the summer in the Ross Toronto Center forums. A member said, hey, the transparency is looking really good tonight. I'm going to go out to such and such a location. And I jumped in and I said, well, hold it. Maybe take a look at the fire smoke data, because that's going to decrease your transparency. It's going to impact your viewing, especially if you're going for faint fuzzies, galaxies, and stuff like that. The weather prediction tools that we use don't necessarily take into account the smoke factor. So I said, if you've got a prediction for good transparency, but there's a high level of smoke or particulate from forest fires, then you need to subtract that factor from the good transparency and drop it a notch or two. And transparency is usually on a kind of a 5-unit system. So if it's good, it goes below good to poor or below average or something like that. So So that all of that sort of triggered me putting together a presentation to talk about all the tools that I use and how how I interpret them. And you'll see by the end of this, it's not just one. That the amateur astronomer needs very specific information, and I think that a lot of the weather sources that you might sort of casually use just don't give us what we need. On the nightly news, for example, the weather person might say that it's going to be clear tonight, but that probably just means it's not going to rain. You got to think about the target audience. They're sort of pitching the weather for civilians, and they have questions like, do I need to take my umbrella to out tomorrow, or do I need the parka and the woolies? Do I need to shovel the driveway tomorrow morning? That's kind of their target market. But astronomers have very specific needs. We want to know if the air is going to be transparent, if it's not going to be opaque. We want to know if the air is going to be steady. That's the steam conditions, and your normal sort of weather resources don't necessarily show that. And it drives me crazy when web pages or the nightly news shows the barometric air pressure in this sort of number format here. Do you know what 102.1 kPa means? Do you know what that means? You need to know the context, how it's relevant for your elevation given the standard atmosphere at sea level. And again, you need to know if it's increasing or decreasing. Some of the web resources that you use might show the barometric air pressure value, but you need to know if that's been adjusted or corrected for the elevation, and you need to see a trend indicator. And a lot of them don't do that. And I don't mean to sound severe, but sometimes when you're watching the news on your TV, the person that's delivering that information is not a meteorologist. So they're just reading a script. Do they really know the science that's going on behind this? So you want to question your sources. You want to determine if you've got some good information. Astronomers need to really actively monitor the weather. Again, we're after very specific information, and I think we need to get good at learning the trends for various things. Frank Dempsey, one of our Toronto Centre members, he's done presentations in the past that get into this in great detail. I'm focusing on the tools, and hopefully that'll help you be able to sort of predict things sort of better. And I think in the end, that means that the amateur astronomer becomes an amateur meteorologist. You'll know more than the sort of average citizen. A little anecdote, I was setting up in the backyard one day, and I saw the neighbors come by, and I said to the mom, hey, why don't you come out when it starts to get dark, and I'll show you and your son some of the celestial objects tonight. We can look through the telescope. So they were excited about that. And then she said to me, how do you know it's going to be clear? And I sort of thought, well, how would you not know that? But I realized astronomers are weird. We pay a lot of unusual attention to the weather. And again, we know really sort of technical things about it when you learn about it. Everything that I'm talking about in my presentation is online. It's available now if you want to go to that website, raskto.ca/weathertools, or you can take a snapshot if you have a QR reader. Take a snapshot of that code, and I think Ward's going to pop that information into our YouTube chat channel as well, so you've got the website there. So everything that I'm providing is on that article. Perhaps the most popular, arguably the most frequently used tool that astronomers use to figure out what's going to go on with the weather is the clear sky charts. And you've probably seen these around all over the place. They come in two different flavors. There's a full version and there's a mini version. You can see that the full versions and the mini ones go out a little bit further. That's a recent change in the last year or so, that instead of 2 nights, we now have 3 nights We know, of course, if we go further into the future, it gets kind of sketchy. We have to use guessometrics to figure out what the weather is going to do. But the next couple of days, we can probably know with fairly high certainty. The clear sky charts give astronomers a lot of great information. The cloud cover predictions, transparency predictions, the seeing predictions. Again, seeing is the steadiness of the air. You can see there's a darkness row, and what we're seeing here is the daytime light, and then it's dark blue for the nighttime, and you can see kind of bluish, light blue colors in between. That's our twilight times. Arnold showed that there's levels of twilight in his presentation. If you get light blue in the darkness periods, that's the moonlight intruding into that. You can see there's also a smoke row. That's a fairly new addition. And then the other weather stuff. Maybe if it's really windy, it'll shake your telescope. High humidity tells you got to fire up the dew heaters. If you don't have dew heaters, it means you're going to get dewed or frosted out. And then the temperature, do you care about that? Lots of people don't like to observe when it's really, really cold, but maybe extreme high temperatures are also not conducive to that. If you're looking at a mini chart, remember that it shows the first two rows only. So you see the cloud cover and you see transparency, but you don't have insight into the seeing. But still, if you see good signs, then that will encourage you to dig deeper into the full chart. And we'll go into one in a moment here. I like these. I think they're really good. I think it's a fairly accurate system. Some people love and hate them, but it's one of my resources that I rely on quite heavily. And in the end, all of the data for the Clear Sky charts comes from the Environment Canada website. Environment Canada is maybe unique in the world in terms of news agents or weather agencies, in that they collect specific information and they do predictions for astronomical use. Again, they calculate transparency and seeing. I was talking to Attila Danko, who packages all this data from Environment Canada, packages it for astronomers. Attila said that Americans often say to him that they're flabbergasted that Canadians could do such a thing. But it just tells you we're serious about astronomy and we're serious about weather. So that's pretty cool. Here are a bunch of websites. Again, this is in my presentation file and in my article notes on the website, but let's go into one. I'll jump into the Toronto website here. So let's have a look at this. And I'll get it here on the screen. So here's the Toronto page right now. Of course, it's a meeting night and it's nice and clear out. So dark blue is good. That's what you're looking for cloud cover, what you're looking for in transparency. You can see after midnight, the transparency is not dark blue. It starts to become a brighter blue. And if you hover on one of the little paint chips, you get a little pop-up. It gives you a specific value. So that can be useful. And when you get white, that's bad. Those are bad conditions. You're clouded out, or the transparency is really bad, or the seeing's really bad. You see the seeing's not great tonight. I was thinking about observing tonight around midnight. I'm trying to split Sirius A and Sirius B, and they're really close together. And Sirius A is really bright, but I need perfect seeing conditions to do that. And the dark, this gray color is telling me that's not going to be good. So I'm not real excited about setting up. You can see there's moonlight encroaching in the early morning here. Now you might notice something interesting here on the Toronto chart. There's another row. There's the ECMWF. That's data from the European forecasting model. They've got some new products. They're pretty sophisticated. Lots of countries are contributing to this. So Attila added in this row for a couple of reasons. It's a backup in case the Canadian CMC data goes down, but it's a way of corroborating things. And you can see we have good correspondence here between these first two cloud rows. Sometimes they disagree, and that can be a little challenging to sort out, but nevertheless useful here. The reason we're getting this row is because it's a sponsored chart. Sponsored charts are possible or made possible by financial contributions to the Clear Dark Sky site. And that unlocks some other features, including forecast history and past charts. So that's kind of nice. The Toronto Centre sponsors 4 Clear Sky charts. So we like to help out this organization and this amateur astronomer provide this weather data. So that's a good look at the, oh, I forgot to mention, if you click on a cloud box or paint chip, it pulls up the a map with the predicted cloud cover. X marks the spot. There's our location, and you can see we're in this trough. Nice. So maybe that's a few good hours of clear observing. That's what's happening right now. So that's cool. So again, I quite like the Clear Sky Chart resources. A member in Mississauga, Brian Gibson, he's made an app. It's quite good for the iOS platform. So you can get this for your iPhone, and you can keep your favorite locations and so on. So check that out. Now I use another resource. I use Clear Outside as well. Again, I don't rely on one resource. Something that I like about Clear Outside is they go further into the future. Yeah, it's not as reliable there, but you can clearly see the moon phases and percentage moon phase is indicated here. It's a very simple system to interpret. Red is bad, green is good. So it's this sort of traffic light system. There's amber colors there's as well, so it's sort of in between. And you could set this up for various locations. It's created by the First Light Optics, which is a vendor or an astronomy shop in the UK. But I found it quite good here. It complements often the other tools that I'm using. Here are some website links for this, but let me go into the Toronto one just to show you the next level of detail that you can see. So again, tonight's looking really good, green across the board. So that's good observing the whole night. You can see there's a sunlight row, there's a moon row, and you can see the moon shows up around midnight. And that gets progressively later through the week. So that's good. We're getting into the dark phase, as Arnold talked about. And but let me expand this row to see, what's going on tonight. So you can expand a day, and in fact, you see there's 3 levels of cloud cover. The International Space Station flyovers are integrated into this. Precipitation, wind, direction, stuff like that. Temperature and the dew point calculations. And when you see that the air temperature is close to the dew point, you need your dew heaters. So I pay a lot of attention to that. Hey, there's a humidity, relative humidity factor. So it's not too bad tonight, so maybe you could get away with not using dew heaters, although there is a frost warning being shown through the whole night. There's air pressure, and when you look from one square to the next, you can see the trend. Yay! So lots of good stuff there. Then you can collapse that day and sort of see what's it like on the weekend. Should I drive up to the observatory or go camping, to do some astro camping? No, it's bad on the Friday, Saturday, Sunday. Lots of red, lots of cloud. So the Clear Outside is a good tool, or the CO tool. I use that a lot. And they have an app for Android and iOS, and it's quite good. It's busy. There's lots going on in that screen, but it's a very good app. And I wrote an article, a detailed article about the app and the website in the RASC journal. So you can read about it in great detail if you want. A fairly new resource to the game is Astrospheric, and it's got some unique features in it here. When you're looking at the website, you got to watch out for something here. If you've got your browser window set pretty small, depending on your zoom scale, the menu that's on the left-hand side may be completely hidden. And if you're trying to get the smoke report or the jet stream details, you need to be able to see that menu. So if it's missing, you got to reduce the scale in your browser or maximize your browser or something like that. Now, the next piece of information to draw your attention to is the upper part of this sort of table, and you can see very much like the Clear Sky charts, we have a cloud cover row, we have a transparency row, and we have a scene row. And you can see when I did this snapshot, this is not a live one, you can see it's dark blue, yay, for the cloud cover, but then it goes cloudy and then white. So we're completely whited out there. And the transparency in the seeing is kind of average through the Thursday night and the Friday that we're seeing here, but Friday night, bad. I like the sinusoidal waves for the sunlight and the moonlight. In fact, when they are synchronized, it means you're in the new moon phase. So that's good. A unique feature is the KP index. So if you're hunting for aurora, that's a good sign. Here are the temperature lines, these line graphs here. The orange is the air temperature and the blue is the dew point, calculated dew point. And when the orange and the blue lines get close together or they touch, you need your dew heaters running to keep dew or frost at bay. You can see that this system goes out a full week, but again, we know to not put a lot of faith into the long range reports, moon details, and so on. Now I have a paid account here, so I'm able to keep locations and a few other features are unlocked. Let me jump into this site. Oops. Let me jump into this site quickly, and I've got the one for the Halifax region. We Artash and Arushi were talking about using the telescope out at St. Mary's University, and the MRO and ARO are out there as well. So I regularly monitor the weather in Halifax as I use those telescopes. So you can see in Halifax, we're under a big blob of cloud. Look at that trough over southwestern Ontario. So that's good. Let me flip to my local location, and you can see now it's centered just above Toronto, and you can see dark blue, yay. But the seeing, again, bad. We saw that was shown in the clear sky chart. So good correspondence between these two tools. But we're going to have to run the dew heaters after midnight, so you can see what you're up against. When I click on some of these different time slots, you can see the map is changing, and watch the paint chips down here, they change as well. So the paint chips are giving me specific details. There's the 7-day report below. So it's not a bad tool. I like it. There's some quirky things about it. There's a convoluted login system for it, but it's a quite a good resource. And they have an app, and the app is pretty good. Again, a bit busy, lots going on, but good information there. Another site that I use is Good to Stargaze, or GTS. What is most unique about this feature is that you can apply criteria. So if you have a certain tolerance in terms of humidity or brightness by the moon, or a temperature restriction, you can activate criteria, and then you'll get red or green indicators. If you have a single violation of any criteria in a row, then it will trigger the far right-hand row, the Good to Stargaze column, it will switch to no. You can see there's a pocket here from 9 o'clock to just after midnight where I meet all my constraints or my criteria. So this means there's a short window there to do some observing. The next nights looking good all the way through. You can see there are boxes here that are black. That means I don't have criteria applied for those. So it's a really nice site. It's very, very useful. You can't store locations for this website, but the app does let you keep locations. So there's the website for it, good2stargaze.com. Very, very nice tool, and you can put, again, your restrictions on that. They have a nice app. It's really crowded, really busy on a small mobile screen slate device. They also have a high-level indicator. So if you're just thinking to yourself, there's nothing on TV, there's nothing on Netflix, should I go out and stargaze? You'll get a yes or no indication here. Again, if you have a single violation, it will trigger the overall summary to be no. So it's quite a useful tool where you can kind of program it for your favorite conditions or desirable conditions. Those are the main weather tools that I've shown you, predictive types of tools, but I use a couple of other resources. I use the Aviation Weather Center satellite imagery tools that are provided by NOAA. NOAA prepares data and makes products for weather analysis, and they get the data from the NASA satellites. So those two agencies or administrations work very closely or hand in hand. Know that weather generally prevails in Ontario or Canada from west to east. So a lot of times I'll look at the satellite imagery and I'll see what's coming from the west and how quickly it's moving towards my location. When you select the Detroit-Windsor part of the map, you get a zoomed in view and you can see a lot of southwestern Ontario is shown here. In this case, in the color infrared imaging, red is good and blue and green is bad. So you want to see dark red here. And if you can see right down to the ground, then that's a good sign. You'll also see with a trained eye, you'll see smoke blowing through the atmosphere as well. So that's a good resource. There's the visual imagery. Again, we can see right down to the ground, little lakes and stuff like that. So very transparent air in a lot of that image. There's the website for it, aviationweather.gov. That's a US website /satellite that'll give you those maps. So quite good. Of course, I recommend you go to the horse's mouth, that you go to Environment Canada, and you can get lots of great information here. I think a lot of people ignore this. Apparently they have an app. I've never tried it, so I can't comment on that. But I often look at, sort of in the late afternoon or early evening, I look at the current temperature, the current pressure, the current humidity. I look at the predicted dew point. If I'm going out this evening, I look at the prediction for tonight, and then I look at the weather for the next morning. If I'm planning a whole weekend thing, I want to see that a few days are looking good. I believe Environment Canada uses the little icons here with great care or accuracy. When you see the moon icon with stars, that's transparent air. If you see the moon with stars and a little cloud, not transparent air. I think they're very, very careful about that. Let's jump into the website for a moment here. So I'll go to the Toronto page. So let's jump into that, and we'll see what's going on tonight. Clear, transparent, nice. It's -3. The air pressure is rising. There's the 101.3 kilopascals, but they show the trend. Thank you. Current humidity, that's pretty low, 55. Clear now, clear tomorrow morning or tomorrow in the day. So that's a good sign. It looks like we have a clear patch here. And I'll read those descriptions. Sometimes I copy these into my notes. So I find this quite useful. And of course, at Environment Canada, you can get lots of other stuff, radar imagery and jet stream maps and things like this. And I'll just scroll down a little bit. There's sunrise, sunset times. And there it is, astronomy in the Canadian Weather Agency's website. So you can tell that they're providing relevant, important data. Now, all the tools that I've just shown you, I have issues with some of them. The point is that not one tool gives me everything that I want. So that's why I use a few. If you read down through a column, you will not see green check marks all the way through. For example, in Clear Outside, they don't show transparency. They don't show seeing. It's the Canadian source that does that. So again, I use lots of tools and I do my own sort of analysis of that data. So I hope that's clear that you shouldn't rely on one. Again, this whole thing was sparked by, no pun intended, by the fire smoke that was happening in the summertime. So if you look at a clear sky chart in the summer where there's smoke, where there's forest fires in the area, and then smoke penetrating into that area, you'll see a warning line down at the bottom or below a full clear sky chart, and then the smoke row, you start paying attention to that, and you want to see dark blue, but light blue and gray, that means it's eroding from the transparency, which is already not great in this snapshot. You can specifically use firesmoke.ca, and this will show you fires, how many, where they are, and then you can animate this and it will show the smoke blowing into the area. You can see at the end of this clip that there's smoke that comes right into southwestern Ontario. So that's very useful information, again, in the summertime. when we're trying to accommodate for that. The US has an equivalent tool. I look at both. I look at the HMS to see what smoke is coming into lower Ontario. So again, specific tools for looking at particulate and smoke from forest fires. So for me, you can see I use lots of tools and I'm interested in lots of things. I'm always paying attention to the moon phase. I want to know if there's going to be significant cloud or not. I want to know what the seeing is, but that doesn't necessarily stop me from observing. I just, you know, if it's a fairly clear night, I'm going to go out and I'll deal with it, or I'll adjust my plan for the seeing and the transparency conditions. I pay attention to the humidity and the dew point. That tells me if I need to haul out my dew straps, if I need to, if I need to bring out my sealed lead acid batteries. Is wind a factor for you? Will it shake your scope? Is temperature a factor for you? I'll go out in any temperature, but I just want to know, you know, how many layers I need. Here's a snapshot I'll show you in a minute of another sort of way I analyze my weather data, and you can see there's blue in lots of charts. Woohoo! And 2 nights, yay! When I see that, I usually set the scope up in the backyard and do a few nights of observing. I set up a few projects. Now, if you're good with HTML, you could build your own weather page. I did this. I made a portal where I'm aggregating all the information. Phil Chow has done one as well, where you can pull in the data. You can see I've got the mini charts for clear sky charts. There's mini versions for the clear outside. I have little applets from the Environment Canada website. That's the jet stream from Environment Canada that impacts on seeing. I've got the moon phase showing. You even have an aurora indicator. And I've got links to some other tools that I use from time to time. I'm using Windows, and on the Windows environment, I use a tool called Rainmeter. And it allows me to put little applets or widgets on the screen. And I don't know if you can see it, the little black circle there, there's a new moon. So new moon phases, I'm usually paying a lot of attention to the weather indicators, but you can see it's a little bit unsettled, but I monitor the weather in London and in near Newmarket and so on. And I hacked, I built those ones, by the way. I built the mini clear sky chart applets for Rainmeter. And then the weather one here, I hacked it to just present information in a better way. It shows the barometric pressure, but it does not show the trend. And I haven't figured out how to program it yet to do it, but it should be fairly easy. I keep track of the old value and compare that to the new. There are lots of other weather apps out there. Some of you might have favorite ones. Maybe you've already done it, but type them into the chat window if there's other tools that you like or use, particularly that are good for astronomers. I'm not big fans of some of these other resources. I've tried a few here, so they're not my go-to ones, but maybe you like those for whatever particular reason. But again, there's obviously lots of tools out there. So that's it. I went a couple of minutes long. Sorry about that. But hopefully I've been able to give you good information for helping you plan your sessions better, know what's coming. You can amaze and impress your friends and family members as you predict the weather with a high degree of certainty. Again, hopefully this will help you know whether it's worth hauling all your gear out in the backyard or whether you should drive a long distance. And hopefully this has helped you with some trend analysis as well. So thank you.
Great. Thank you so much, Blake, for putting this together for us. Once again, I know it takes a long time, so we appreciate your effort. Ward, do we have any questions for Blake?
Sorry, online's very quiet tonight, but I had one. Do you have a tool that you use to predict trips, like far enough into the future for a trip or something like that?
I think your question was you're doing trip planning and maybe far into the future you want to sort of have some better prediction tools. A couple of answers or ideas for your consideration. When you look at Environment Canada's website, I don't know where it is exactly here. There's historical climate data. And then for regions, you can see there's historical stuff, averages and extremes. So diving into that can help you see what the averages are for a certain location in Canada, obviously. And in fact, I did a kind of a deep dive into that once. Somebody was asking about clouds and cloud cover and, you know, the percentage of clear skies. So I went through the Environment Canada data and pulled up a report for Buttonville. And this is kind of bad news. But you can see the month scale down the left-hand side here. So January is at the back of the box. This is a three-dimensional surface graph that I did. So January, February is at the far back, and then November, December is at the front, close to us here. I have a time scale, and I organized it where midnight's in the middle. So that's our prime observing times, right? And you can see that there's gray sort of surrounding everything here. No surprise. In January, February, in October, November, December, there's a lot of gray skies. And you can see in May, June, July, we get blue and dark blue. And that means we have the least amount of cloud, or we have greater chances of clear skies. And you can see that's happening, interestingly, in the evenings. So this sort of shows you for the Buttonville, Richmond Hill area, you know, kind of what the sort of the good times are. If you want to do serious astronomy in January, February, no, you won't be able to do it. There's a high chance of clouds in those occasions. So that's data that's all sort of harvested and collected by the Environment Canada website. And I was also thinking about the RASC Observers handbook. RASC members get this for free. It's a perk of membership. And in it, there's, I don't have the page reference handy, but there's information about weather average conditions for all of North America. And a lot of people use that when they're planning trips like eclipse trips. You know, in 2024, a lot of people might be going down to Texas to try and view the next solar eclipse, total solar eclipse that happens over North America. It will pass through the Buffalo area and near Hamilton and stuff like that. But a lot of people are choosing not to stay close to home. They want to go to Texas because of obvious clear sky opportunities that are presented. So again, check the RASC Observers Handbook for the section on predicting weather conditions or cloud cover there. And there's an article and a number of maps there that are quite useful.
Excellent. Great. Thanks very much, Mike.
Thank you.
I don't see any other questions online.
Thanks
All right.
again.
Thank you, Blake. All right, so that concludes the speakers lineup for this evening. We need to go to announcements with Tom Luton.
Thank you very much, Paul. Friends, rascals, and astronomers, lend me your ears. Let's get through some announcements. So, as Paul was saying earlier, we've got two types of meetings. We have our recreational astronomy nights, and we have our speakers nights. Both of them are here on YouTube. If you're watching us live, say hi in the chat. Enter some questions for the presenters. If you're a new member, please introduce yourself. And if you're from far, far away, let us know where you're from. So our next speakers night is on the 17th of February. Professor Hilding Nielsen will be discussing indigenous astronomies, stories of the sky, and indigenizing the Drake equation. Right here on YouTube, 7:30 p.m. on the 17th. Our next recreational astronomy night is the 3rd of March at 7:30 p.m. Dennis Gray will be handling the sky this month. Carrie Ann Leckie Hepburn will be discussing adventures in lightscaping under the night sky. And Jerry Villa will be telling us about Tycho Brahe, Danish astronomer, and his legacy. If you'd like to present something, get in touch with Paul, please. We'd love to hear you. We've got a joint lecture coming up with the Royal Canadian Institute on the 28th of February. Professor Keith Vanderland will be discussing strange signals, fast radio bursts. It is a free event, but registry is required. Please click the link. So Toronto Centre is famous for its outreach. At least we were before COVID hit. We are currently planning virtual star parties with the Ontario Science Centre, with Millennium Square and David Dunlop Observatory, the St. Clair O'Connor Community, the Dunlap Institute, with Brownies, Cubs, Scouts, and schools, and with new observers to visual astronomy. Please contact public education at raskto.ca for more info, or if you'd like to help. And as suggested, all of our observing sessions, our group observing sessions at Bayview Village Park, Long Sault Conservation Area, and Ontario Science Centre are suspended until further notice. As well, the Carr Astronomical Observatory is closed until further notice. Only maintenance activities are currently going on up there. Now, even with things shut down, we have a real need for volunteers to come and help. So if you're a Rask Toronto Centre member, if you're interested in helping, you've got some free time, give a shout to our volunteer coordination team at volunteer@raskto.ca. And if you really want to help out, we've got a number of job postings that need filling. As I've been saying beforehand, we need a new light pollution committee head, but we're also looking for national council representatives, for members to run and be a member of our marketing committee. The AV committee, who you've heard being praised at least twice tonight, also needs some help to keep putting on this wonderful level of video that we've been enjoying for the last year. Again, contact volunteer@raskto.ca. Our ongoing stellarium training courses. Sorry to say that the level 1 courses scheduled for the 22nd and the 1st of March are full, but we do have space available for the level 2 course that will be on March 22nd. More level 1 and level 2 courses will be offered, including at least one level 1 course that will be scheduled for Pacific Standard Time, as opposed to Eastern Standard Time. We've also got level 3 courses and a Stellarium for Educators course in the planning stages. raskto.ca for more information. This is where I plug the benefits of Rask membership. So you've seen what we do, and you've heard about some of the things we do. Please join us. You can renew online at secure.rask.ca. If you're facing financial difficulties because of how COVID has screwed everything up, the Rask does have an emergency fund. It is completely confidential. Drop a line to Adela at the national office at mempub@rask.ca. We've also got some products for sale in our e-store at the national office. The Observer's Handbook has been mailed out, but if you sign up, you get a free copy. The Observer's Calendar is still available. No in-person sales this year. We would normally have a great big box at the front of the auditorium when we have our lectures at the Science Center, and we'd be selling them ourselves. But this year, if you want one, you're going to have to get it directly from National Office. And with that, I'd like to wish you all a good night. I want to thank you very much for joining us. You can follow us on social media. Please like and subscribe and click the notification bell. Be safe and keep looking up. Good night, everybody.